So today's lecture is on Chapter 4, Introduction to Classes and Objects. So today's lecture is actually a little bit different in that we're not really going to be talking anything about syntax of C# today. We're going to kind of take a more top-level view of what objects and classes and what software engineering is in general. So before we actually get into the lecture, just a few things to kind of cover with the class in general is just if you have questions, make sure you send the entire project to me. It's just so hard to answer questions if you don't send the entire project versus just copying and pasting a piece of code or just trying to describe your problem. It's almost impossible for me to answer that question if you don't send the whole project so I can debug it and take a look. Also, turning in assignment. Let's go over that again. So let's say we've got this assignment number 1 here. We've written our program, now it's time to turn it in. So what you want to do is you want to go into your projects, and let's say here's our assignment number 1, and we want to zip this up. So you can use different programs to create a zip. I have this program called WinRAR on here, so I just come in here and I just say add to archive, I click zip. Again, whatever program you use, do OK, and you notice I've got the zip file here. Then all I do is just change it to .zip, and then I email this particular zip file to me. And that will be what I actually then grade when you turn it in. That way it doesn't get blocked by your email carriers one way or another. So with your first assignment, again, I would always recommend you send that file and another email just telling me you actually sent that. So today's lecture is all about concepts and not exact syntax of C#. So what we want to discuss is software engineering. And that's why you're getting this degree. Anyone could pick up a book and learn C#. Anyone could go on the tutorials on the internet and learn C#. So what is a software engineer? Well, that's the difference between just knowing the syntax of C# and be able to write programs and actually being able to solve problems with C#. So what makes you worth so much more money and time and effort than someone they could just ship overseas and have this job done online? Well, again, it's that problem solving, the software engineering. There are times where it makes sense for companies to, have an overseas account and have someone do these type of projects because the reality is they're just going to be able to do it cheaper. And you're going to be more expensive and benefits and all that comes with it. So for the type of programs that have very, very well defined requirements. So I've got this web page, it's very basic. Here's a web page, here's what I want it to look like. Here maybe some screenshots of what I think I've designed it out. Here's exactly what should happen when you click this button. They have to enter in their first name, last name, this piece of information. If they click this link, it goes to this page, and it's very well defined out. Those are the type of programs that there's not a lot of thinking that goes involved, and there's not a lot of problem solving because all of the problems have been sort of defined within the requirements. Hey, when you click this button, it needs to go to here, and you need to process the payment, kind of a thing. So there's a lot of very well-defined requirements that this other person can just take it and just write C# syntax for exactly what they've been told to do. And those are the kind of programs that do get shipped overseas, the web pages that sort of just get created with the cheapest bidder. However, that's not what you're here for. You're here to become a software engineer. And so not only do you want to learn the syntax of C# or C++ or Java during your time here at Weber State, you also want to learn how to solve problems using those languages. And that's where your value comes in. That's what that degree means. Is it's not, I can't just regurgitate syntax. I can sit down with you and we can figure out, Mr. Customer, what your problems really are, and I'm going to come up with the best solution for how to solve those problems. The language doesn't matter. Again, what I learned in my college years, which was 14, 15 years ago, is completely obsolete now. .NET, I took one .NET class and it was just literally the day that .NET came out. Nothing I learned back then is applicable today with databases, networks, internet. It was all just coming about. So over the years, I've had to keep constant learning on my syntax and my different languages, but your customer doesn't care. They care about you solving the problems they have. So why are there different types of engineers and what do they do? So you're going to become a software engineer. So you're going to solve problems using software right here in Visual Studio. You're going to come in here, you're going to say, your customer is going to say, well, I've got this machine on an assembly line and I need your software to monitor this machine and make sure it's not overheating. And if it does, I need you to alert this particular person, or shut down the machine so it doesn't break. And so you're going to be in charge of writing the software, become a software engineer to solve this problem. So you save the health of this machine. So maybe it's a car factory, for instance, and there's this robotic arm that's putting doors on the car. And so you're constantly monitoring the voltages, the temperatures, the positions, the rotation axis, all these different things for this robotic arm. And you monitor all this stuff, and then maybe you create a display screen that's showing health and status and what the machine's actually doing at that particular time, so an end user can monitor that anytime they need. Now, you also had to work with a mechanical engineer. So there was a mechanical engineer. Their job is to solve problems mechanically. So with this, again, this robot arm that's putting car doors on, it was their job to create the joints and to create the movement and actually build this particular piece of hardware. And you also had to work with electrical engineers. So the electrical engineers worked with mechanical engineers to deal with all the wiring, all the voltages, how this thing's going to get power, how it's going to communicate back to the software, etc., etc. So these different type of engineers all had their specialties, and they worked together to solve this common problem. And so it's nice to be able to at least have a very basic understanding of these other types of engineering so you can communicate. That's kind of what I've learned dealing with a lot of mechanical and electrical engineers, where you may need to be able to talk about voltages and communication protocols and things like that. So it's really important to understand there's lots of different engineers out there, not just software engineers. So mechanical, electrical, structural, chemical, all kinds of engineers. So what is an engineer? It's just someone that has a specialty with solving a type of problem. So a software engineer solves problems through software, right? A structural engineer working maybe with bridges or buildings is going to deal with structural issues and problems. And they have that specialty of solving problems. So someone just can't walk in off the street, and figure out, the structural integrity of a bridge. The same that someone couldn't walk in and just create a software program that can control this mechanical arm on the showroom floor. So the next thing is as a software engineer, the one thing that a lot of people forget about is that there are lots of different languages and there is no one right language. I can't tell you how many times I've talked to engineers and they just think that C++ is the right answer for everything, and that is just not true. You need to pick the right language for the type of problem you need to solve. If it's a low level memory intensive type program, it's probably going to be C or C++. But you're not going to use C to write this massive internet web page application or with this really nice advanced GUI interface. It's just not going to make sense most of the time to do something like that. Probably C# or Java is going to make more sense. Oh, I've got an internet application. There's all kinds of great internet languages that are going to make sense in that, like JavaScript, for instance. So just don't ever think that there's ever one language for the job. And that's kind of something I've noticed over the years with some engineers kind of get hung up on, that is that they only think that all they ever have is this hammer for their tool, and they forget that they've got a whole toolbox that they can actually look into. So the next idea that we want to talk about is what really are classes. Because for the whole rest of this class, we're going to be talking about classes and objects in every single lecture. So we really want to make sure we understand what classes are, what objects are, and what they're made up of. So classes are just groups of attributes and methods. So a class we can think of as a blueprint. And just like for a house. So we've got this blueprint that an architect draws up, and it's just a piece of paper, and it's just a drawing. That's all this blueprint is. We can't live in this blueprint. We can't use this blueprint for anything except creating houses. So we can create a house from this blueprint. So we can sort of stamp out and build as many houses as we want from this one blueprint. And for every house we create, we can then customize that house. We can have different color flooring, different color paint on the walls, different cabinetry, etc., etc. They're all the same structure, but we can change the interior design of it. Well, that's exactly the same in our code. So we build classes such as an employee class, a customer class, a date class, a tic-tac-toe class like for one of our assignments, maybe an invoice class for a business, that contains, what items the customer bought and their cost. And so we create these classes, but that's just a blueprint. You can't use these classes. It's just a way of defining some sort of real world object we're trying to represent. So what we can then do is we can take this class and we can create an employee object, for instance. And so we can create as many employee objects and then fill up those employee objects with their individual first names, last names, employee information, things of that nature, or create as many invoice objects as we want. So let's go ahead and let's write some code just to kind of get our heads wrapped around this particular concept. Now, you do not need to know any of this syntax right now. We're going to have entire lectures dedicated to pure syntax on classes and objects. So I'm not going to explain a lot of the syntax that I'm writing. Let's just focus on the concepts of what I'm writing. So let's go ahead and let's create a class. So what I can do is I can right click over here on my project and I can say add, and you can do new item, or I can just come down here to class. And let's say we want to create an employee class. So this pops up and let's call this CLS employee. So we add that, and here sure enough we create our employee class. I'm going to make this public so everybody can see it. And so we can see over here, here's my employee class and here's my form. So now this is the blueprint. We're going to now create the blueprint for what it is to hold the employee information. So now we want to first always comment our class. So this is an employee class. It holds information about them, etc. So we write some sort of summary about the employee class and what it does. So within our class, the first thing we want to create is the attributes. So like if we have a house, the attributes would be like paint color, the type of floor, the type of cabinetry, things like that. For our employee, it would be something like, string S first name. So what I've done here is I've made this private variable of type string called first name. Maybe we also want something called last name, and we want an employee ID. Let's make this an integer type. So now I've created 3 attributes within my employee class. So now there's this keyword called private. I'm actually going to make one of these public. So what I'm saying here is that outside of this employee class, I don't want anyone to know about first name. So they can't actually access first name. They don't even know it exists. This is a form of what's called data hiding. When I make something public, people using this class can actually see last name. And this will make more sense when we actually instantiate the class and use it behind this form. So I've got a private first name, a public last name, and an employee ID. So this is what makes up an employee, and we can have as many attributes as we want for our employee. So now that we've created these, we also have to make sure that we create our comment. So this is the first name. Come down here, the last name. Employee ID. So always make sure as you go along that you write good comments. So now the next thing is that because these are private, we need to have a way of outside this class to be able to access these private variables. So what I'm actually going to do is create this public method, and what it's going to do, its whole job, and a property is just like a method, but it's a special kind of method. It's a way that we can control access to our private attributes. And so we've got this private attribute. I'm going to close down these comments so we have a little more room to work with here. And so I've got these private attributes, and I want to control access to how the user gets these attributes, or they set these attributes. And so what I can actually do now is, if I wanted to, I could actually make sure I could check this value that gets passed in via the value keyword, and I could validate it, make sure it wasn't blank, or it was at least 10 characters long, something to that nature, and I could validate it here in my set. And so when I get the value, this is when I say something like, employee.firstname, and I return that value into something else. If I say employee.firstname equals ABC, that's going to call the set, because I'm setting that value. And we'll walk through this when we actually instantiate the class in just a second. So I've got my private, my public attributes, and now I've got a public property that controls access to my private variable first name. Now this public one, I'll make this one public also, so we can see it outside the class. I'm just going to collapse that down so we can see it. Now again, do not worry about the syntax. We're going to go have a whole lecture talking again about private and public attributes, what it really means, what these gets and sets, and the syntax. We're going to go over all of that in depth. Right now, we're just talking concepts. So the next thing we can do is we can, for instance, create a public method. So we're going to create public so people outside the class can use it. Let's say it's going to return a string, and we're going to say this, get full name, for instance. And maybe you pass in the employee ID, or actually we'll just say get full name. So what we've done here is we've created this method called get full name. And so what we want to do is we're going to return the first name plus the last name. And so that's going to be able to be used outside the class, so it's public. We're going to return a string. The method's called get full name. And as always, we want to create our comment. So this returns the full name. We'll just say full name is what it returns. So this is a method that's methods take some sort of action. So you're doing something. This is the verbs. So get full name, insert employee into the database, validate employee data. So methods do something with the data that you've passed into it. They're going to do the work. Now this particular method was public, so if we want, we can actually create a private method called do some work. And I'm not actually have this method do anything, but what I'm going to do is when you create private methods, the whole purpose of a private method is to help you do some work within your other methods, within your code. Because no one outside this class, when they're using it, knows that this method exists. This is only for internal use of the method, because people outside of it can't use it. So this is just to get some sort of work done inside your class. So now the last thing I want to talk about here is the constructor. So the constructor looks just like a method, but it doesn't have a return type, and it's the name of the class. So when we actually instantiate our employee, you can see this is where, when we say new, this is where it actually gets created. So I could default some values, for instance, the first name, last name. So when you create an employee, it's going to default first name to ABC. So this is any code that anytime when you create a new employee, you automatically want this code to get ran. So when the compiler, the .NET and the CLR are instantiating this employee, and it's actually creating some memory to hold this employee object, the first name is going to set to ABC during that process, and that's called the constructor, is what we're doing there. So now let's talk about how we're actually going to use our class. So we've created this employee, and maybe this employee class, it probably mimics the exact same table columns in our Oracle database, for instance. So our Oracle database has a table called employee with first name, last name, employee address, employee ID, social security number. And so what you'd do is, in memory, you'd actually create a class that has all those same columns as our database table, and then we can go out to the database table, pull that data back, and we can fill up in memory this class here. So now let's go back to our farm code, and we're going to actually use that employee class. So what we can do now is we can say, all right, I want to instantiate my employee class, and we do it just like a double or integers, how we started off. So CLS employee, and you can see it pops up. Now this is why we use XML comments, because you can see right here, this is an employee class. It holds information about them. So if we come back over here, you can see that this is the comment that it's showing in that IntelliSense. So if you had written this, let's say you had 10 developers on your team at work, and your job was to write the employee class and allow the other developers in your team to use the employee class. Well, they don't care about how it works. They just want it to work to help them get their job done. And so when they get this class, you need to give them information on how to use it, because again, they don't have access to your code if you just give it to them in a DLL, for instance. Or even if you did give them the code, they don't care. They just want to be able to say, hey, employee dot, or CLS employee, and they want a description in the IntelliSense on what it really does. So let's say employee 1. So this is a really key concept to understand of what I've done right here. This right here has not actually created an employee object. At this point in time, all I've really done is created a blueprint. I've not actually created the house at this point in time. This is just the blueprint. This is what you call an object reference, because it's going to refer to an object. It's going to hold the reference in memory to an object. Now what's nice about C# is we don't have to deal with pointers and addresses like we do in C++. We don't have to manage any of that. And so when we have this variable here, behind the scenes though, it really does just create an address that points in memory to where this block of memory has been allocated to hold an employee object. So in order to actually create the employee object, we come down here, employee, and we always have to use the new keyword. The new keyword tells the compiler, the .NET CLR compiler, to actually allocate some memory for this employee object. And you can see it. I pressed that, it came up with employee. Now this is going to call that constructor of our class. So that's why it actually looks like a method, because it actually is. It's going to call this method or this constructor of our class. So the new keyword tells the compiler, hey, I need to actually go out in memory and allocate a chunk of memory that can hold this employee object. This returns a reference to where that's located in memory and stores that reference here in our object reference. So it's very key to understand that sort of language of what we're talking about. So this creates an object reference. This instantiates the actual object and puts the reference here into our variable. So now we can actually use our employee. So now we've actually instantiated our house, right? We've built our house from our blueprint. So now we've actually created an employee object from our class. So now that we've done that, we can say employee 1 dot, and we can start accessing the data inside of our class. So for instance, we can see first name. Now if we come back over here, you'll notice that first name was actually private, so it's S first name. But what actually pops up over here, you can see, is first name. This is actually our property that we created right here. You can see this is our public property. But you can't see est first name because it was instantiated as private, or it's created as private. So anything that's private is not going to be able to be seen when you're actually using this class. You can see there's no such thing as est first name. Now there is s last name, because this was actually created as public. So we've come over here, you can see public s last name and public I employee ID. So those are going to pop up in our IntelliSense. And so we've got our public property, our public s last name, and our public employee ID. We also can see our method called get full name, and there's our IntelliSense. This returns full name. So if we wanted to, we could say s first name, we could set that equal to Sean. We could say, employee 1 dot last name equals Cowder. And so this is just like building our house, and then this is painting the walls, and this is doing the cabinetry. So we've created our employee, and now we've started to fill up that employee with the individual pieces of data. So we could do the exact same code now. except we could do employee 2. But now what I'm going to do is I'm actually going to put this all on one line of code. So what I've done now is I've said, okay, create a new employee object, again, of the same type employee, instantiate it, but this one line of code is the equivalent of these 2 lines of code. So generally you just do it this way. And now I can set the second employee's information. And so now we have 2 employees in memory that they're of both the type CLS employee, but they have different information stored in them. So if we want to now call that method to return the full name, I could come up here, it's called get full name, and you can see there's no parameters, but I have my IntelliSense, and I could actually go ahead and call that method. I can highlight it here. I can also right click and go to definition, and it'll jump me right to that code here. So that's kind of a nice way of how you can move around your code if you need to figure out, as you're debugging or you're needing to fix some errors, something to that nature. The other thing is, let's say there's a whole bunch of code and you really understand where you're at right here and you don't want to lose your place because it kind of get hard to follow through with what you're doing. You can right click on here, do something called peak definition. And what's nice about that is it kind of creates this little sub window called a peak window that is just looking in this other class here, but it's kind of nice because it just creates this little sub window. And that way you can kind of look, oh, okay, that's what this get full name does. You can kind of look at the code, or see, kind of scroll through it, and then you can just close it down. So it's just a kind of an easy way to peek into the code. Again, you just right click, do peek definition, or you could actually go to the definition. So you just click that, and it pops up with this window. And I can actually write code within here, and it will change it over in that other class. So just kind of another way that you can navigate around. Now the one thing that you have to be very, very careful of. So let's go ahead now, let's create a third employee, and now let's say CLS employee dot last name. So now we set the last name. Now what mistake did we make here? Well, this code doesn't make any sense that we just wrote. Why doesn't it make any sense? Well, does it make any sense to try to live in a blueprint? It makes no sense whatsoever, right? The thought of it would never even cross your mind. Well, that's kind of what it's saying here. It's like you haven't even assigned anything to this variable. You haven't actually created an employee object. So this will always break. You would never be able to do this in your code. And so if I run this, you can see it's even giving me a compile error that says, hey, you can't do this. But let's actually trick the code into thinking you have instantiated it. What I can do is use the null keyword. And you can see now it's saying, hey, you've assigned a value to it. I can do this just fine. Well, what's really happening here? Again, you can't live in a house, you can live in the house, but you can't live in a blueprint. So I have this null employee object reference, and I'm trying to assign the first name or the last name to it. So when I run this code and it hits this breakpoint, you notice if I highlight this, it actually says null. So there's no object that's been instantiated. So I press F10 and it's actually going to blow up on me. And this is going to be one of the most common errors that you're going to get. So you need to memorize this error message. You're going to get it so much during your career and during this class. And it's object reference not set to an instance of an object. And so let's kind of dissect what that's really telling us. What it's saying is hey, your object reference, right? This is this right here. Remember I said when you create this variable, it's called an object reference. It's a reference to your object. So it's saying your object reference, which is your employee3 variable, is not set to an instance of an object. So you have never done this new object. So you have not created a new object. So that's whenever you see that object reference not set to an instance of an object, you know that somewhere you're missing a new keyword. You forgot to instantiate the object before you used it. I promise you, you're going to get this error all the time during this class. And as soon as you get that, kind of back up, set a debug point to wherever you're at, and take a look at that object, and if it says null, okay, sure enough, and then start tracing your steps and say, well, where should this have been instantiated? Because maybe this object got passed into your method and you expected it to have already been instantiated. So maybe you need to check to see if it's null before you use it. Or maybe it's your own code and you just forgot to instantiate it before you passed it into this method. So again, this is something you need to be really careful of when you're creating your code. So the next thing we want to talk about is inheritance. And you need to be really careful with inheritance in that, understanding where all these methods come from and how you actually architect your code with inheritance is kind of a daunting project if you're an architect of a program, and how things are relate to each other and these kind of things. So what is inheritance? Well, it's just a form of software reusability. And so you'll notice up here we're inheriting our Form 1 class. It's just a basic class, but we're inheriting from base class form. And so that's what makes this look like a window, is because we're inheriting from the form base class. So this is our derived class, but we're inheriting from the form class. Now, there's actually lots of inheritance going on here. I can actually right click on the form and do go to definition. And you'll notice that's actually going to take me to this, what's called metadata. You can see metadata from the form class. Now there isn't any code in this, it's just a whole bunch of comments. But you can actually see everything that makes up the form class. All the events, all the methods, all the attributes. And we can scroll through here and you can take a look at what the person had to write when they created the form class. But the person that wrote the form class inherited from something called container control, which is another class that someone wrote. So we can right click on that, go to definition. And so here's what someone wrote for a container control. And they inherited from something called scrollable control. And so we can go to definition there, and they inherited from control. And this inheritance is going to go on and on all the way up until the very top base class of something called object. And that's a test question. It's very important to understand that all classes in C# are derived from the base class object. Everything automatically is inherited from your base class object. Now, that also means that our employee class here, even though there's no inheritance that we explicitly defined, it is actually inheriting from the object base class. Again, don't worry about the syntax and how you would write all this and how you actually get that stuff to work. I'm just showing you that automatically it's inherited from the base class. So when we come over here and I use this employee, did you notice that when I did this that I got things like equals? I never wrote an equals method. I never wrote a method called getHashCode or getType or getToString. Well, that's actually part of the object base class that I get for free because everything inherits from the object base class. So you can see it even tells you right here object.toString. So I can call toString, but whoever wrote the object base class is who wrote that method. So it's just important to understand that everything is derived from this object base class. So the next thing, when we come into our employee class, and again I could say, okay, I can right click here, go to definition, it jumps us back over here. So we've got all these private and public attributes. So these are class attributes. Then within our methods themselves, I can create my own variables. Now these are method level variables. So these variables only exist from the time they're instantiated to when this last bracket, when they are no longer in scope. And so the common language runtime actually takes care of all the memory for you. So it hits this line of code and the CLR says, okay, I need to instantiate this, create some memory for it. When it hits this line of code, it says, okay, I can go ahead and clean up this memory because it can never be used again. So that's what's nice about .NET, is it actually has this ability to clean up the memory for you, where something like C++, you manually have to do it. The only other thing I want to go over is this last little piece of information that we talked about in the last lecture, is just remember that there's all this behind the scenes code that Microsoft is writing for you in this designer file. You would never change this code, but as you write code in your designer, it's going to update this designer file. where it's initializing the components. Again, here's my form 1, and it's setting all of these variables for my form. So even my form here, you'll notice I was using my constructor to set up all of these employee classes. So if I were to right click and now run it, you can see the first thing it's going to call is the form 1's constructor. And so this instantiates the form 1, but oh, by the way, not only are we creating all those components, we're going to create some employee objects. And so when we create these employee objects, you'll notice that it's null at this point. I press F10, and now it actually comes up with some debugging information. I can do it right as I'm debugging. I can actually get the values for all public and private attributes. So while you're debugging, see, I can actually see these private attributes right within my debugger. And if I want to, I can go ahead on the fly. Oops, I forgot to put quotes around it. As I can come in here, whether it's on employee, or I can just highlight the first name. And so you can see how it highlighted the quotes, and I forgot to put the quotes on the end of it since it's a string. I can also click this little symbol here, and just kind of a little text visualizer so you can see the value of it. But while I'm debugging, again, I can click this little symbol here, and that way while you're debugging it has a little nice, so even if I press F10 for instance, you can see the value now is still here over here to the right. The other thing I can do is I can take my employee object here. Let's close this down. I can go up to Debug, Windows, Watch, open up my Watch window, paste in my object, then I can open up down below, and same thing, I can see what all my values are set to. So you can see last name right now is set to null, but if I do F10, you can see that it's now set to counter. So it executed that line of code. Well, maybe I wanted to change it, so I come back up here. Oh, you know what I really meant to set this to was DDDD. So now, did you see what I just did there? While the code was actually executing, I changed that code. And then I press F10, and you can see now last name is actually DDD. So that is immensely powerful. If that doesn't impress you, I don't know what will. If you're not a nerd and that impresses you, I'm sorry, I got nothing better in this class. So I literally wrote code on the fly. I didn't have to stop the program and then recompile it. On the fly, I changed code, it recompiled it, and just started executing right along that piece of code right there. So that is a really, really good time saver, where just as you're debugging, oh, I forgot a semicolon, I forgot, this should be first name and not last, instead of last name, or I'm calling the wrong method here, something to that nature. It's really nice. Inline, you can change that code. So the next thing is we've always been pressing F10, and you notice that steps over a method. Well, sometimes you want to step into a method. So to do that, you press F11. So I press F11, and you can see it actually jumps into my code for CLS employee, and now I can do F10. If I did F10, it's going to jump over, do some work. Now if I drag that back up here and press F11, it's actually going to jump down in to do some work. You can see it jumps back out, hits my return statement. I can take a look and see what these values are. Press F10, and that's going to jump back to his full name, and I can continue debugging on. So as you get your assignments and you start working on them, and again, you get these exceptions like object reference not set to an instance of an object, or some other type of exception because you tried to do an invalid cast, or your values just aren't computing like you'd like them. Maybe you're, again, you do that 17 divided by 5, and and you're expecting a decimal number to come back and you're only getting an integer. Well, what you do is you set your debug point and you start just stepping through, and you take a look at your value, and then you say, okay, the values are correct. I press F10. Oh, that just turned into an integer. Why didn't I get it? Why isn't it being stored as a decimal? Oh, integer division. And then you can make the change. Even right there while you're debugging, you can go ahead and change it. Or why isn't the first name being set correctly? Again, set the debug point and just start walking through your code. And you do things like that. Then the next step to how to solve the problem, because remember, that's software engineering is, solving those complex problems. So if it's still not making sense in the debugger and it looks like it's working correctly, then you go to the internet, or your book, and you start googling different error messages, or whatever way. There's all kinds of code websites that can, the other users will have the same problem, and you can kind of figure out how they solved that problem. And then after that, if you keep spinning your wheels and you still just can't get your head wrapped around it, which is perfectly normal. We all do it, especially at this level where you're kind of junior, senior level, and it's your first time in C Sharp. Just shoot me an email. Just put a breakpoint just like this in your code, and then when you send me an email, say, hey, I've got this Form 1 class. It's inside the constructor. I've set a debug point. Right here it's throwing an exception or it's not calculating the value correctly. Could you help me solve that? And then I'll take a look, I'll debug it, and I'll fix the problem, email it back to you, and kind of tell you what went wrong. So this is just a general top view of what being a software engineer is all about. So again, today's lecture had nothing to do with syntax. It's just the concept of how you would use C# to solve a problem. So in this particular instance, it was, hey, we had a whole bunch of employees and we need to pull that data from the database. We needed to fill it up in memory, and then maybe we needed to then create a report for our end user. So that was our problem. So we created this employee class. We pulled all that data from the database. We filled it up here. We got their full name. We manipulated, massaged the data however we needed it to look, and then we generated some report, or we created an Excel spreadsheet, something of that nature, with some some pie charts and things like that was helpful to the end user, who is like a manager who just wants that data printed out kind of nice so they can present in a briefing or something to that nature. So that's software engineering.